one row, 4 zeros are gone. Similarly, if you delete the first column, a wholesale number of zeros are gone. In fact, all zeros are gone by just 2 lines. What we do now is a simple process. Look at those elements which are uncovered, not deleted by the lines. We can see that this region is not deleted. Okay, look at those numbers and we can see that the minimum number in this uncovered region is 1. So subtract 1 from all uncovered elements. So here -1, here again -1, here also -1, -1, -1. Everywhere we are putting -1. We will be putting +1 wherever our horizontal and vertical line intersects. We can see that this is a horizontal line and this is a vertical line and they are intersecting like this. So we will be adding +1. Actually we were subtracting 1 everywhere, but at the intersection we will be adding. And so we get the next table as follows. It is again A, B, C, D, 1, 2, 3 and 4.
0.
Okay, we have 0, 2,
5, 8.
5 and 8.
0, 0,
0, 0, 1,
2,
2,
0, 0,
0, 0,
1,
1,
2,
2,
1,
1,
0,
0, 0, 0. Again we repeat the procedure. What we do now is, once again we are going for the assignment. Look at the first row. There is only 1 0. A row or a column with 1 0 is most qualified for the assignment. So this row is qualified. We'll assign here. And as soon as first row was selected, the column, corresponding column will be deleted. Actually zeros will be deleted. Okay, again now look at the second row. If we look at the second row, then again there is only 1 0 left. So this is done and these zeros are gone. Now if we look at the first row, there is no 0 left. In the second row there is no 0 left. In the third row as well, no 0 available. In the fourth row there are 2 zeros, but anyway we would love to have 1 0. So now we'll look at the things column wise. In the first column no 0 available. In the second column no 0 available, but in the third column yes, 1 0 is available. Okay, but since it was a column which was selected, the corresponding row will be deleted. So we could make 3 assignments. Okay, so total number of assignments equal to 3 in this case. Mind you, in the earlier part it was 2. So we have improved a bit, we reached to number 3. But then again it is not good enough because we had 4 people and 4 jobs. So we'll have to do the same exercise again. What we do is, again we go to the next part where we'll try to cover the zeros by the minimum number of horizontal and vertical lines. Okay, so we go to next part, which is A, B, C, D, 1, 2, 3, 4.
0, 0.
Okay, our numbers are 0, 2, 5, 8.
0, 0, 1, 2. Same. Then 1, 0,
and
0,
last
0.
row is 1,
All
0,
zeros.
0, 0. Now we'd love to cover all zeros by minimum number of horizontal and vertical lines. If we again look at the first column, it has a big number of zeros, so this is deleted. Okay, now again if you look at the last row, it has 3 zeros, so those zeros are gone. Now only these 2 zeros are left. So if you delete the second column, all zeros are gone. Once again look at the uncovered part. If you look at the uncovered part, again 1 is the minimum number. If 1 is the minimum number, then 1 is subtracted from all entries and the same 1 is added where the intersection was made between the lines. So this is an intersection spot of horizontal and a vertical line, so the same 1 is added here. Again here also 1 is added. So actually we subtracted the minimum element of the uncovered region from uncovered elements and we added the same number at the intersection. So our next table will be again A, B, C, D, 1, 2. By the time you must have started realizing that assigning jobs to people is not very easy.
0,
So these numbers are 0,
2,
2,
4,
4,
7.
7.
0, 0, 0, 1. Same.
Third row is,
Same.
and the last row
2.
is
1, 0, 0.
again the same process. We would love to assign the values. Again, first row does the perfect job, 1, 0. So select it and delete the other things. Now look at the second row, it has 2 zeros. We are not happy with that. Third row has the same situation. Fourth row is not even good. Anyway, columns are always to our help. In the first column, no good news. In the second column, again there is not a better news because there are 2 zeros. The third news, oh, it is worse actually, 3 zeros. But the fourth column is nice enough. It is only 1 0. So we do it. Since we selected the column, the row will be deleted. I mean, zeros in the row are deleted. Okay, again we'll start the story from the scratch. First row, no zeros. Second row, 2 zeros. Third row, again 2 zeros. Fourth row, no scope. The first column, okay, has no scope. The second column has 2 zeros. The third column has 2 zeros. And the fourth column has no zero. So anyway, there is no row or a column where we have a single zero. So this leads to a tie. If you look at the second row, there are 2 zeros. Third row, there are 2 zeros. Second column, there are 2 zeros. And third column, there are 2 zeros. So actually it's a common situation, almost a tie at 4 things. So anyway, this suggests that there is a multiple solution. There are more than one optimal solutions. So anyway, we can select anyone. Suppose we select the second row and we take any 1 0. Then since we selected a row, the column has to be deleted. Okay, and finally now the third row has 1 0. So if we do that, this 0 is gone. So we reach to a solution which says that A should be given the first job, B should be given the second job, C should be given the third job, and D should be given the fourth job. Okay, so the final output will be A should be given the first job, B should be given the second job, C should be given the third job, D should be given the fourth job. If we look at the values according to the original problem, once again we'll look at the slide with the original values, which is on the screen
This.
earlier. Yeah, this one. If you look at this slide, we can see that this gives the original data. So salesman A is located at the first area, so that cost is 42. Then B goes to 2, so that is 25. C
20.
goes to 3, that
20.
is 20, and E goes to 4,
12.
that is 12. So 2 and 5, 7 and 2, 9. 4 into 6 into 8 and 1, 9. So if we do this assignment, then the cell will be 99 units. So that is the best possible answer with us. So this is the Hungarian method, and I hope you remember what it was for minimization. We did the same actually for maximization, and the process is the same except the first initial step. So this was Hungarian method, and final solution is reflected in the screen now. That is this. We go to the next. The next variation is unbalanced assignment problems. This is not a new concept actually. We had unbalanced transportation problems in transportation as well, but this is not even that much complex. This is more complex. We have this unbalanced assignment problem with restriction on assignments. We can see on the screen that there are 4 machines. Basically the issue is that we have to put our machines into, say, our godowns. We have 5 locations for godowns available to us, so 4 places to put and only 4 machines. So this is an unbalanced assignment problem. Our screen data again says that the first machine, you'll have to look at the screen again, first machine, if we put at the first location, the cost, okay, will be 9 units, say. If the first machine is put in the second location, okay, the cost is 11 units, and so on. Similarly, other machines are there. Now, first thing you can see that if you look at the second machine's row, then there is a dash in location C. This simply reflects that machine 2 cannot be put at location C because of some reasons. Maybe you can assume that machine 2 is very big and the location C is not as big. So you have a limitation, you have a restriction that machine 2 cannot be put in location C. Similarly, machine 3 cannot be put on location A. So once again, some physical limitations are there. So not only that, this is an unbalanced assignment problem because there are only 4 machines and 5 locations, so it's a 4 by 5 problem. And secondly, we have some additional restrictions as well. The question is what to do. Like transportation problems, we'll make it balanced by adding a dummy machine. As we see in the next slide, we have added a dummy machine 5, which is actually not available to us. And since there is no machine available to us, cost is naturally 0 everywhere. At the same time, you can see that machine 2 we cannot put at location C. So we are putting some cost, capital M. Capital M is a very, very big cost. We cannot afford it. So once again, this reminds us of big M method and simplex. So you can say this is cocktail of big M method and transportation method, where we are assigning 2 big M's, one at machine 2 to location C, and other is machine 3 to location A. So this is how we make it balanced. First of all, now there are 5 machines, one is virtual machine, and 5 locations are always there. We are assigning some very negative kind of values, very big values we can say, to locations where we don't want to go for. So this is what it is. Now our job is to take care of this issue. So again, we'll solve this on Teletop. So we look at the data again, what we have. This is our unbalanced problem, and once again, as you know, this is a minimization case, though it's not very complex. What we have is machine 1. So we have 5 machines, 1, 2, 3, 4, 5,
and 5 locations.
And 5 locations. They are A, B, C, D, and E.
9,
okay.
9.
Values are
9,
11,
15,
15,
10, 11.
Second row is
12, 9,
9, M,
10, 9. Third, M, 11, 14, 11, 7. Fourth, 14,
that is 14,
8, 12, 7, 8.
and 8.
Last 0, 0, 0.
And of course, those nice zeros. Okay, so this is a problem with us. And again, we are interested to apply a Hungarian method, a same method with a bit of change, because we have something, very fishy, capital M with us. So we again look at that. Our Teletop figures says that first row has a minimum number 9. So 9 is to be subtracted from every number. The second row has minimum again 9. So this is 9 subtracted. Anyway, M is something where we are not interested at all, so we don't bother about it. Again minus 9 and minus 9. Again, we are not interested in this. Oh, this time it is 7, right? In the third row, the minimum is 7. So 7 is subtracted everywhere. In the fourth row, again 7. So 7 is subtracted everywhere. Okay, and in the fifth row, the minimum is 0. So nothing to be done. Anyway, we are not interested in that place as well. Okay, so our refined table is this. We have 1, 2, 3, 4, 5, where A, B, C, D, E.
Then 0.
Okay, we have 0,
2, 6,
6,
1,
1,
2.
we have
3
3
0
0
M
M
1
1
0
0
M
M
4
4
7
7
4
4
0
0
then 7
7
1
1
5
5
0
0
1
1
I mean zeros
and
also.
zeros. So the first step is already done. The minimum of each row is subtracted from each row. As you remember the second step also, now the same process is done for columns. Look at the first column. The minimum is 0. That's a good news. We have to subtract 0 from everywhere. Look at the second column. Again, we have minimum number 0. So 0 is subtracted from everywhere. No change in the column. Similarly, third row has 0, fourth row has 0, and fifth row has 0. I'm sorry, we are referring to columns actually. First column has 0, second column has 0, third column has minimum 0, fourth and fifth also have minimum 0. So all columns have minimum number 0. So 0 is subtracted from all 5 columns. And what better than that? There is no change in the table. So the first step, subtracting minimum element of each row from that row is done. Second step, minimum element of every column subtracted from every column, that is also done. So we are ready with this table now, and now we are going to make the assignments. So look at the rows. Again, like the last case, the first row is a wonderful row, only 1 0 appearing. So we are making an assignment there, and since it was a row, the corresponding column zeros are deleted. Now look at the second row, then there are 2 zeros, but third row is quite good, so there is only 1 0, and since it was a third row selected, the respective column zeros are gone. Okay, now look at the first row, there is no 0 available to us, but now in this revised situation, this second row has 1 0. So we make an assignment here, and corresponding column entry are deleted. Again we revisit row 1, no 0 available, row 2, no 0 available, row 3 has no scope, row 4 has of course 1 0. Make it there, and the column is deleted. And finally, if you look at the fifth row, there is 1 0 available, so we can make an assignment there. So if you count the boxes 1 2 3 4 and 5, we have total assignment